Hi, welcome to our math. Today I'm doing a series of videos on linear programming. My first step in this process is going to be to translate this story problem into a series of inequalities. Okay, so a nutritionist has been asked to prepare a special diet for certain patients. She's decided that the meals are to be prepared from two foods. The meals should contain a minimum of 400 milligrams of calcium, 10 milligrams of iron, 40 milligrams of vitamin C. Each ounce of food A contains all of these elements. Each ounce of food B contains all of these nutrients, as well as some cholesterol. How many ounces of each type of food should be used in a meal so that the cholesterol content is minimized? Aha! So that extra category of cholesterol is our minimization. Okay, so let's see what we have. We will say that X, actually we'll just do A and B. A is food A, and B is food B. Okay, so the food has things we want. We want a minimum of calcium. We want a minimum of iron. We want a minimum of vitamin C. Okay. So, right here it says that food A contains 30 milligrams of calcium. So each ounce of food A. So this is per ounce. So each ounce of food A has 30 milligrams of calcium, 1 milligram of iron, and 2 milligrams of vitamin C. It also has cholesterol. We'll get to that in a second. Each ounce of food B contains 25 milligrams of calcium. It has a half a milligram of iron and 5 milligrams of vitamin C. If we come back to the beginning, the nutritionist decided that the meal should contain a minimum of 400 milligrams of calcium. So when we add the two parts of food together, it has to be greater than or equal to 400 milligrams of calcium. We need more than, at least, if not more than 10 milligrams of iron. So this needs to be greater than or equal to 10, and we have greater than or equal to 40. The last of our basic constraints are going to be that the amount of food we have per ounce has to be greater than or equal to 0. Okay, this is the series of conditions we are setting on the amount of food. And what we want to minimize is the cholesterol. And food A has 2 milligrams of cholesterol per ounce, and food B has 5 milligrams per ounce. All right, so now we have it. I'm going to scooch up our story problem so we have way more space to work. We have our variables, we have our conditions. Now we want to graph. To graph these lines, because the numbers are so big, I am going to use the intercepts. So I'm going to say 30A plus 25B equals 400. I say equals because this is just to graph the line. I don't need to worry about the inequality until I shade the lines, which will be after I do the basic graph. I'm going to graph with my intercepts. So I'm going to set I'm going to set B equal to 0, so 30A is equal to 400, and when I divide, A is going to equal 13.3 repeat. I'm going to set A equal to 0, divide, and B is going to equal 16. Those are the horizontal and vertical intercepts that define this line. Okay, 2A, sorry, we skipped one. A plus 0.5B equals 10. If I set B equal to 0, I have A equals 10. If I set A equals to 0, I have B is equal to 20. Now I do 2A plus 5B equals 40. If I set B equal to 0, I have A is equal to 20. If I set A equal to 0, B is equal to 8. All right, so now I'm going to sketch my graph, and usually at this point I say scale doesn't matter. And it matters only because when you graph 3 lines, you're going to have 2 lines that cross, and the third line is either going to go above or below the cross, and we kind of need to know that much. So I'm not going to do a huge amount of scale, but I am going to put 10 here, 20 here, and 13.3 about here. It's close scale, it's not precise. For my B's, my vertical axis, I have 8, 10, and 16. So if I put 8 here and 16 here, and 10 will come, 8, 16, and 20. So 20 will come up here. Okay, so the 13, 3, and the 16 go together. The 10 and the 20 go together. And the 8 and the 20 go together. Okay, so here's my basic graph. Now I need to do the shading because I have all of these different regions, and I need to know which region is the important region. Okay, so for my first graph, actually for all 3 of my lines, notice that the line that I drew is the minimum amount, which means for all 3 of these, I'm going to shade above. I could test a point, but to save a little bit of time, I'm just going to go with the shorthand that the line has to be greater than 400, and the line, if it was equal to 400, would be the line as I graphed it. That gives me 1, 2, 3, 4 corners. Remember, my last 2 lines were that A is greater than or equal to 0 and B is greater than or equal to 0, which forces me into the first quadrant. So there we have it. This is my feasible region. It's boundless. It's unbounded. It goes off to infinity. That happens a lot with minimums. If this was a maximum, we couldn't maximize something that goes off to infinity, but we can have an unbounded region if we are looking for a minimum. Okay, so what we did is we first translated it, then we graphed it. Even though we have an infinite number of points in this region, the minimum cholesterol is going to come from one of these 4 intersection points. All of it coming from food A, all coming from food B, and these 2, which is a combination of A and B. I need to find out where these intersection points are. So the first line, 30A, 25B, 400, that had the 13, 3, and the 16. This is my line 1. The second line for the iron with the 10 and the 20, this is my line 2, and this over here is line 3. All right, for this intersection point right here, it's the combination of line 1 and line 2. If I look at line 1 and line 2, I have the 30A, 25B, and 400. What I'm going to do is I'm going to multiply the second equation through by negative 30. So I'm going to say line 1 minus 30 times line 2, so that my A's cancel out. Line 1 is 30A plus 25B equals 400. Negative 30A, negative 30 times 0.5 is 15, negative 15B, and negative 30 times 100 is negative 300. I always multiply through by the negative and add down to avoid dropping negatives and making sure I don't add when I mean to subtract. All right. 10B is equal to 100, so B is equal to 10. I'm going to put that into my first equation. 30A plus 25 times 10 equals 400. 30A plus 250 equals 500. 30A is equal to 250. Sorry, this is 400. This is 150. A is equal to 5. I want to test to make sure that that is the 0.510 works in my second line. So is 5 plus 0.5 times 10 equal to 10? Yes. So this point right here is 510. Okay, this point is combining lines 1 and 3. If I look at 1 and 3, I think eliminating the B would be easier this time because 5 goes into 25 and I only need to multiply by 5 this time. So for lines 1 and lines 3, I'm going to take line 1 minus 5 times line 3. Okay, so line 1 is 30A plus 25B equals 400, and then a negative 5, so negative 5A, negative 10A minus 25B equals negative 200. When I add down, I get 20A is equal to 200, or A is equal to 10. I'll put that into my first equation again. So I have 30 times 10 plus 25b equals 400. 300 plus 25b equals 400. 25b equals 100 when b is equal to 4. As always, we do a quick test. Is 2 times 10 plus 5 times 4 equal to 40? 20, 20, yes. So 10, 4 is my next point. So that point right there is 10, 4. Okay, whew. So now, translated, graphed, found our points. I told you that one of these 4 points, 0, 20, 5, 10, 10, 4, or 20, 0, would be the ordered pair that will minimize our cholesterol. So I'm going to test them all. So if I test 0, 20, I'm going to test 4 times 0 plus 5 times 20, which is 100. If I test my next point, 5, 10, I get z equals 2 times 5 plus 5 times 10, 50, 60. That's going to equal 60. If I test my third point, which is 10, 4, I get that z will equal 2 times 10 plus 5 times 4, 20, 30, 40. And then if I test 20, 0, I have z is equal to 2 times 20 plus 5 times 0, which is 40. So we actually have 2 minimum values. So when I write my answer, I have to acknowledge both of those as being minimum values. So they can minimize the cholesterol at 40 milligrams with 20 ounces of food A or a combination of 10 ounces of food A and 4 ounces of food B. All right, there we go. We have our answer. I hope you've enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I will see you on the next video. Thanks.